Okay, let's review some geometric terms that we are going to be using in our equations unit. We have vertical angles, angles across from each other. These angles are equal. Supplementary angles, angles that form a straight line. These angles add up to 180. Complementary angles, two angles that have a sum of 90, and then the triangle sum theorem, which we know that in a triangle, all three angles add up to 180. So we're going to see how we can use that information along with equations to solve some geometry problems. First, I want to look for triangles. Do I see a triangle? What do we know about triangles? All three angles add up to
180.
180. So that means that this 99-degree angle, this 39-degree angle, and this unknown angle has a sum of 180. Since there's only one missing, I can find that measure. So 39 plus 99 plus something equals 180. I'm not going to use x because x is already used over here to represent a different value. Maybe I can use y. So I find this by adding 39 and 99, which is 138 plus y equals 180. Then I would subtract 138 from 180, and that would give me a value of 42. So this measure is 42 degrees. So we use the triangle sum theorem to find the first measure. Now we see that we have two lines that intersect at this point and therefore form vertical angles. They actually form two pairs of vertical angles. Vertical angles are across from each other when two lines intersect. And like they look, they are equal in measure. So I can say that this angle's measure and this angle's measure are equal. This angle's measure is represented by 5x plus 2, and we know this angle's measurement is 42. So again, those two measurements must be equal because they're vertical angles. So let's solve this two-step equation by first getting rid of the constant. Plus 2, the inverse is minus 2. What I do to one side, I do to the other side. 42 minus 2 is 40, equals 5x. And then we would divide both sides by 5 to get an x value of 8. This is just what x equals. This is not the measurement of the angle. Again, if we go back and plug it in, if we substitute 8 for x, 5 times 8 is 40, and 40 plus 2 is 42. So the measure of the angle is 42 degrees, but if it says solve for x, then the answer to this question is x equals 8. Another problem, I see a triangle and I see a straight line at this angle. So I see two things I'm going to end up using. I'm going to use the triangle sum theorem. The triangle sum theorem allows me to find this missing angle inside the triangle. So since x is used here, we'll again use y to represent that angle. So my first step is to find the missing angle measurement inside the triangle. I know that whenever I have a triangle, the three angles add up to 180 degrees. So y plus 95 plus 28 equals 180 degrees. Combine my like terms, 95 and 28 is 123. So y plus 123 equals 180. Subtract 123 from both sides, and I'm left with y equals 57. And since y does represent the angle measurement, we know that this angle is 57 degrees. Now that we know that angle, we can use that angle to find the value of x, and that is what the question asked for, solve for x. See where we have a line, a straight line, also known as a straight angle, half of a circle. So these are two angles that are supplementary because their measures add up to 180 degrees, seeing that they form half of a circle or a straight line. Anywhere we see two angles that come together to form a line, we know that those angle measurements have to add up to 180. So I would set up the equation x plus 135 plus 57 is equal to 180. Combine my like terms, 135 plus 57 is 192. Subtract my constant, and I'm left with x equals negative 12. Remember, x doesn't represent the angle measurement. X just represents the value that you would plug in to get the measurement of this angle. So if x equals negative 12 plus 135 is 123. So the measure of the angle is 123 degrees, and 123 plus 57 does in fact add up to 180. But if it said solve for x, then we're looking for x's value, which is negative 12. Okay, I see vertical angle, and a triangle. I'm trying to solve for x. If I knew this angle measurement, then I would be able to say that these two vertical angles are equal. I don't know this angle measurement. I do know one of the angles inside the triangle. I need the other angle. I can get this angle because these are vertical angles. So you see there's multiple steps. You kind of have to fill in everything you know before you can get to what am I going to do to solve for x. So vertical angles here, 39, so 39 degrees. Missing angle inside a triangle. So this angle measurement, and this angle measurement. The three angles inside of a triangle add up to 180. So 39 plus 81, I'll use y for now to represent this angle measurement. Have to add up to 180. 39 plus 81 is 120. Plus y equals 180, subtract 120 from both sides, and y equals 60. That represents this angle measurement, so that's 60 degrees. Now that we know that this angle is 60 degrees, and we know that these two angles are vertical, then we can state that x plus 68 must equal 60 degrees. Subtract 68 from both sides, and x equals negative 8. Not degrees, just the value negative 8. When you plug negative 8 in, negative 8 plus 60 gives me the angle measurement of 60 degrees. Solve for x, x equals negative 8.
All right, let's do like one more.
Okay. Skip to, this is just a triangle, so they all add up to 180. This is just a triangle, they all add up to 180. This is two lines that intersect, but we don't have angles across from each other. We have angles that are adjacent, which means they're side by side. They form a straight line, so we would say x plus 44 plus 2x plus 1 equals 180. Combine like terms and solve. Again, I notice a triangle, but I don't have the three angles. I just have this one angle inside the triangle, and I have the angle adjacent to us. So we have two angles that form a straight line. These two add up to 180. And my last one is two angles that form a 90-degree angle. This is the symbol that represents 90 degrees. So we have 2x plus 1 plus 67 equals 90 degrees. And we would solve to find the value of x.
And that's it, right?
Yes.